All right, welcome back, period 2. This is Algebra 2, 10.7. This is the last lesson on solving. So you will need a calculator because some of our answers are going to have decimals. And so go ahead and get a calculator now. And so you can see how we're going to use it to solve these equations. So these are the last types of equations that you have to know how to solve. All right, so this first one, we want to solve these equations. This is an exponential equation, and we know it's exponential because there's no logs anywhere in the problem, right? So 2 to the x equals 5. All right, now, if you try to figure out what x is, it'd be pretty tough because if you go 2 to the first, 2 to the second, 2 to the third, none of those are going to actually equal 5. We can get close, but we're not going to actually get it to equal 5. And so this happens when we can't get the bases the same. Okay, we have a base 2 and a base 5. You're not going to ever get them to be the same. So these are the steps that we're going to use to solve these types of equations. Okay, again, these are exponential equations where the bases could not be made the same. So the first thing we have to do is make sure we isolate, isolate the base. All right, and I mean the base with the exponent, okay? Meaning if there's a number in front of the base being multiplied or added or subtracted before or after, but on the same side, we've got to move that over to the other side. All right, we want to just get that base to the exponent by itself. Okay, so that's step 1. And then step 2, once we've isolated the base, what we're going to do is log both sides. Log both sides. All right, so I'll show you how we're going to do it on this one, 2 to the x equals 5. All right, so if I put log in front of each base, okay, I've logged both sides. As long as I do it to both sides, then it's legal. You're allowed to do it. Okay? All right, so I've logged both sides. Now, step 3, we're going to bring the exponents down in front. All right, and we're just using one of the log properties. All right, so this exponent, x, can get moved down in front. So it's x times log 2 equals log 5. All right, and then we're just going to get x by itself. Okay, solve for x, or whatever variable in the problem. So here, to get rid of the log 2, I can divide both sides by log 2. All right, now x is by itself. This is the exact answer, log 5 divided by log 2. All right, it looks weird, but that's what the exact answer for 2 to the x equals 5 is. Now, we're going to go ahead and take our calculators, and we're going to actually find the decimal. We're going to go 3 decimal places for each of these. All right, so log 5, and then we're going to divide that by log 2. Log 2. Now, if your calculator opens a parentheses, just make sure you close it after each number. All right, so if you hit equals, you should get 2.322. All right, we'll go 3 decimal places. So this is the approximate answer. The exact answer is log 5 over log 2. All right, so that's the basic steps to solve these types of problems. All right, so let's try number 2. So we have a base 5 and a base 11. All right, you're never going to get these to be the same, so we have to log both sides. Okay, so log 5 to the x equals log 11. We're going to bring the exponent down in front, so x times log 5 equals log 11. And now we're going to divide both sides by log 5. All right, so here's the exact answer. Okay, again, this is exact. And then let's go ahead and put in our calculator and we'll find the decimal. All right, so log 11 divided by log 5. So that's going to get us 1.4898. All right, so the third decimal place, 9, is going to move up to a 10, which makes the 8 move up to a 9. So it's going to be 1.490. Okay, kind of look at it as 1.489. So 89 will go up to 90. All right, so number 3. So this one, the base to the exponent, 12 to the x, is not isolated. All right, so we have to subtract the 2 over first. So 12 to the x equals 8. All right, so now we can say the 12 and the 8, we're never going to get those to be the same base. All right, so we can log both sides. All right. Then we'll bring the exponent down in front. So x log 12 equals log 8. And then we can divide by log 12 on both sides. And so here's our exact answer, log 8 over log 12. Well, then we'll find the decimal. Log 8 divided by log 12. And again, we'll round it to 0.837. All right, so number 4. Our base is 5 to the x power. And it's being multiplied by the 2. So we're going to divide by 2 first. So 5 to the x equals 8. And then we can see we can't get those bases to be the same. So now we log both sides. And we have log 5 to the x equals 8. Bring the exponent down. And then we're going to go ahead and divide both sides by log 5 to get x by itself. All right, so there's the exact, and then we'll find the decimal. All right, so log 8 divided by log 5. So 1.292. All right, so number 5. The base is already isolated, so now we'll just go straight into logging both sides. That's log 7. And we'll bring the exponent down in front. All right, so bring that whole 4x down. Equals log 7. All right, so here we're going to go ahead and divide. Okay, you can divide by log 3. That will cancel that out. But because it's being multiplied by 4, we could divide by 4 now also at the same time. And that'll cancel the 4 out. So here's our exact answer. Okay. Now you could do it separate and write log 7 divided by log 3 equals 4x, and then divide that answer by 4. So log 7 divided by, and do 4 log 3. Now I opened the parentheses before I put the 4 in, so I have a parentheses 4 log 3, just let you know. All right, so 0.443. All right. Now another way you could do this is punch in a log 7 divided by log 3. Hit the equal sign. It's like 1.771. Then divide that answer, hit divided by 4. Divide by 4. And then you'll get 0.443. So either way, but you should get that answer. All right, so number 6. Can't get the bases the same. It's already isolated, so we'll log both sides. So log 11 to the x plus 2 equals log 15. We'll bring the exponent down in front. So x plus 2 log 11 equals log 15. So here we're going to divide both sides by log 11 first. All right, so we have that x plus 2 equals log 15 over log 11. And now I'm going to subtract 2 on both sides. All right, now I'm subtracting 2 from the entire log 15 over log 11. All right, so that's the exact answer. So don't make it like log 13. You can't subtract 15 minus 2. So punch in your log 15 divided by log 11, and then make sure you hit the equal sign. Okay, and then subtract 2. Just hit minus 2. All right, so negative 0.871. All right, and then number 7, again, we'll log both sides. Log 15 to the negative 2x equals log 8. Bring the exponent down in front. All right, and then we'll divide both sides by log 15. Now, if you want to divide by negative 2 at the same time, you can. So all that cancels out. So you divide by negative 2. All right, so log 8 over negative 2 log 15. All right, so let's go ahead and put that in the calculator. So again, you can do this as 2 separate problems. Do log log 8 divided by log 15, hit the equal sign, then just directly hit divided by, and then negative 2. All right, so that's going to be negative 0.384. Okay, you could also hit log 8, divided by, open parentheses, negative 2, log 15, close it, and I think you have to do 2 closes, and then hit equals. All right, so go ahead and try that on your calculator. All right, so go ahead and turn it over. All right, so now we're going to be solving log equations. All right, so when there's only one log in the problem, we have to change it to exponential form. Okay, so 1 log, change to exponential form. All right, so 1 log in the problem, go to exponential. All right, so if you remember when we did this before, converting from log form to exponential, start with the base, okay, and then kind of think of that way. So 2 to the 5th equals x. 2 to the 5th power equals x. And then we can simplify this side, 32. X equals 32. All right, so number 9, we have 1 log in the problem. All right, and then, so natural log, remember, is a log that has a subscript. That's e, a base e. All right, so now changing to exponential form, e is our base, to the 6 equals 2x. And then we can divide by 2. So this is the exact answer, e to the 6 over 2. And then we can also find the decimal answer. Okay, so we'll find our e to the 6th. Okay, so find your e to the x button, e to the 6, and then divide that answer by 2. We'll go 3 decimal places again, 201.714. All right, now if we have 2 logs on the same side, just like the other lesson, when there's 2 logs, you have to condense into 1 log. Okay, now we have addition, so this will condense into a multiplication problem. 5 times x equals 2. All right, so then our base here, remember, is 10 when you don't see it. So 10 to the 2nd equals 5x. So that's 100 equals 5x. Divide by 5. X equals 20. All right, so let's move down to 11. All right, so again, we have 2 logs on the same side, so we have to condense. And subtraction to a fraction, x over 3. We have 1 log in the problem, change to exponential. 4 squared equals x over 3. 16 over 1 equals x over 3. We're going to multiply diagonally. That's 16 times 3, which is 48. And 1 times x is x. All right, 12. 2 logs on the same side, so we condense into 1 log. Addition condenses to multiplication. So that's x squared times 4. I'm going to write it as 4x squared. Okay, we have 1 log in the problem. Go to exponential. 3 squared equals 4x squared. 3 squared is 9. All right, so we could divide by 4 here. Then I'm going to square root both sides. Square root. All right. And when you square root this, remember you can, when you have a fraction, you can split it up, square to 9 and over square to 4. All right, and don't forget plus or minus here. All right, square to 9 is 3 on top, and square to 4 is 2 on the bottom. All right, so plus or minus 3 over 2. All right, and 13, 2 natural logs on the same side with addition. So this is going to condense into a multiplication. X times 2x. Okay, x times 2x.
Joseph, how you doing?
All right, so let's finish this. So x times 2x equals 4. All right, so we can multiply the x and 2x. That's 2x squared. All right, so we have 1 log in the problem, so we have to go to exponential. All right, so make sure you understand natural log has base e. So now when we write this in exponential form, the base is e to the 4th equals 2x squared. All right, and then here we can divide by 2, e to the 4th over 2 equals x squared, and then square root it, plus or minus. All right, and that would be fine. You know, you could simplify this if you want to, but on this kind of a problem, I would be fine, you know, with this answer, square root e to the 4th over 2. All right, and then we could throw that in the calculator. All right, now to put this in the calculator a little bit easier, you could do square root e to the 4th over square root 2. That might be a little easier. If you can put the whole fraction in, that's fine also. And even if you wanted to simplify square root e to the 4th to e squared, that is the same thing. All right, so let's try this, see if we can put this in the calculator. Square root, then we're going to put e to the 4th. Okay, you can hit the equal sign if you want, 7.389, and then divided by the square root of 2. All right, so 5.225. So 5.225, and that's a positive and a negative. All right, so that's a little bit different problem. You know, it's on there. Not sure exactly if that would be on a test or not, but just so you can see how to do it. A little challenge problem. All right, so let's do this last one, 14. 2 logs on the same side. Here we have subtraction. So this condenses to a fraction. So x over 10 equals -1. Okay, now we'll go to exponential. So remember, 5 is our base, to the exponent -1 equals x over 10. All right, now 5 to the -1, we can change that to 1 over 5. Remember, negative exponents, think reciprocal. Okay, move it down to the bottom, make it a positive one. All right, and then we can multiply diagonally. So 1 times 10 and 5 times x. All right, and then divide by 5. And so x equals 2. All right. And that's how you do it. When you have 2 logs on the same side, make sure you condense always into 1 log and then go to exponential form. All right, so go ahead and try the homework. If you have questions, send me an email. All right, bye.